పైన రాయమన్నారా ఇది ఉండాలన్నా ఎప్పుడు స్టార్టో చెప్పు స్టార్టా Good morning, students. In the last class, we have discussed about catalysts. The catalysts are positive catalyst, negative catalyst, biocatalyst. In this catalyst, will having different type of functions. It will be takes place. What are the functions? Means the enhancing of rate of reaction, the catalytic function will be takes place. By using the catalyst, every condition, by using the catalyst, this one is reactants and products are there. Every reaction will having some energy barrier, it will be takes place. This energy barrier is called activation energy. If it will be cross the activation energy, then only it converting as product. So, to reach that activation energy, every reactant molecule either there increasing the temperature, in case of gaseous molecule increasing the pressure, or in case of different type of components we are using catalyst. By using the positive catalyst, the activation energy barrier will be decreases. When activation energy barrier is decreases, every reactant easily converting as product. Every reactant easily converting as product. If you are increasing, if you are adding the negative catalyst, the activation energy barrier will be increases. When activation energy barrier is increases, automatically what happen? The rate of reaction will be decreases. So, rate of reaction influencing factors are what about the catalyst. So, based on that thing, here the catalysts are two types of catalysts are present. Two types of catalysts are present. Those catalysts are homogeneous catalyst, another one is heterogeneous catalyst. Homogeneous catalyst, another one is heterogeneous catalyst. Homo and hetero. Here in the name is also there homogeneous. Homo means same. Means if you take any reaction, the reaction means reactant converting as product. If you take any reaction, the reactant converting as product. To enhance the rate of reaction, what we are adding here? Catalyst we are adding. We are adding catalyst. Homogeneous catalyst means, homo means same, means reactant and products, reactants and products, and what we are using the catalyst, these all are having in the same phase. Homogeneous catalyst means reactant, product and catalyst having in the same phase. So, the type of catalysts are called homogeneous catalyst. Homo means same. Reactants, products, catalyst will having all are in the same phase. Same phase means either solid phase or in case of liquid phase or in case of gaseous phase. All in having the same phase it will be takes place. The type of catalysts are called homogeneous catalyst. Homo means same. For example, if you see the some of the examples here, that one is sulfur dioxide. Here sulfur dioxide reacts with oxygen converting as sulfur trioxide. Sulfur dioxide reacts with oxygen, it converting as sulfur trioxide. See that sulfur dioxide is what type of nature? It is a gaseous nature. Oxygen is what type of nature? It is also gaseous nature. What about the sulfur trioxide is also what type of phenomena? It is a gaseous phenomena, it will be there. Sulfur dioxide gas, oxygen gas, as well as sulfur trioxide is also gas, it will be there. Means reactant having same phase and product is also same phase. Along with reactant and product, if you see the here we are using the catalyst. What are the catalyst? Nitric oxide, another one is nitrogen dioxide. Nitrous oxide, nitric oxide, here NO is called as nitric oxide. That nitric oxide is also having in the what type of phase? It is a gaseous phase. Nitrogen dioxide is also having what type of phase? Gases. See that in this first reaction condition, if you see that in the first reaction condition, reactants, products and as well as catalyst is also having in the same phase. So, that is the reason the type of catalyst is called as homogeneous catalyst. Homo means same. All reactants and products and what about the catalyst will having the same phase. Same phase means now this reaction all are in having the what type of phase? It is a gaseous phase. So, the type of catalyst is called as homogeneous catalyst. Another example for this homogeneous catalyst is carbon monoxide. Carbon monoxide reacts with oxygen converting as carbon dioxide. Carbon monoxide react with oxygen converting as carbon dioxide. If we see that carbon monoxide is also gaseous phase, oxygen is also gaseous phase, carbon dioxide is also having gaseous phase, means reactants is gaseous phase, products is also gaseous phase. Now, to completion of this reaction, to enhancing of this reaction, what we are using the catalyst, that is nitric oxide we are using the catalyst. The nitric oxide is what type of phenomenon? That phase is gaseous phenomenon. So, reactant, product and what about the catalyst? All are having in the gaseous phase. So, that is the reason this type of reactions are called homogeneous reactions, and the type of catalyst property is called as homogeneous catalyst. Homogeneous catalyst means reactant, product and whatever here the catalyst is also gaseous phase, it will be there. And one more example if you see that, you know very well in the organic chemistry that when is this functional group belongs to what type of functional group? It is a ester functional group. This functional group is what type of functional group? It is a ester functional group. So, ester is a liquid phenomenon, it will be there. Ester, this one is hydrolysis reaction. Hydrolysis reaction is favored in the presence of acidic medium. H plus means acidic medium. This acidic medium is, this is also in what type of phase? Liquid phase. H2O, hydrolysis means we are adding water, that is called hydrolysis. If we are adding water, that reaction is known as hydrolysis reaction. So, by the hydrolysis, in the presence of acidic medium, this ester undergo the hydrolysis, it is converting as acid and alcohol. Here the product is acid or C double bond OH group. This is called as acid. Which acid? Carboxylic acid, and another one is alcohol. Now, here the bond will be dissociated. In this oxygen area substituted hydrogen and here OH, acid and alcohol is formed. So, in the ester hydrolysis, ester and water is belongs to liquid phenomenon, and another one is the generated products are carboxylic acid and alcohol. This carboxylic acid and alcohol is also what type of nature it is present? It is a liquid nature is there, and what we are taking here acid is also in the liquid form. So, all the reactants, products and catalysts are having in the same phase. So, that is the reason this type of catalyst are called as homogeneous catalyst. Another example, C12H22O11. C12H22O11, it is called as sucrose. It is called as sucrose. Sucrose is a common name is sugar. Sucrose common name is belongs to sugar. The what about the sugar undergo the hydrolysis. When sugar if dissolve in the water in the presence of acidic medium, it is dissociated. Hydrolysis, its form glucose and fructose. It is dissociated as glucose material as well as fructose material. So, this glucose and fructose, this is called as disaccharide. Saccharine means sugar. The chemistry form saccharin is called as sugar. The sugars undergo the hydrolysis. If it will be used, two types of sugared materials, those are glucose and fructose. So, that is the reason that the sugar is also, sucrose is also called as disaccharide. So, in this condition if you are observing that glucose is a liquid phenomenon, fructose is also liquid phenomenon, H2O liquid and sugar is also dissolved in the water is a liquid, and in the presence of acidic medium that is also liquid, all are in the having same phase. So, the type of reason this type of catalysts are called as homogeneous catalyst. Homo means the reactants and products and catalyst, the total reaction are having in the same phase, it is called as homogeneous catalyst. If we take heterogeneous catalyst, hetero means the reactant product, and what about the catalyst will having the different phase reaction, different phases it will be there. different phases, that is called as heterogeneous. In the completion of the reaction, we are using, to enhancing the rate of reaction, we are using catalyst. By using the catalyst, if the reactant and product, then the catalyst is different. So, the type of materials are called as heterogeneous catalyst. The type of materials are called as heterogeneous catalyst. Hetero means different phase it will be takes place. Homo means same phase it will be takes place. So, the best example here, sulfur dioxide and oxygen, it converted to sulfur trioxide. Here how many moles it will be present? 2 moles are there. The catalyst we are using platinum and vanadium pentoxide V2O5. So, this material platinum and vanadium pentoxide, this material belongs to what type of material? Means it is a solid material. It is a solid material. Sulfur trioxide is also gaseous phase, sulfur dioxide is also in the gaseous phase, oxygen is also gaseous. Means reaction sulfur dioxide react with oxygen converting as sulfur trioxide. Sulfur dioxide react with oxygen, it converting as sulfur trioxide. These all are having what type of phase? Same phase. Reactant is one phase, product is also same phase, but catalyst will having the different phase. In the earlier, reactant, product and as well as catalyst will having the same phase, it will be there. Same phase it will be there, that is homogeneous. Now, it is a different phase it will be takes place. Due to the different phase, that reactions are called as heterogeneous catalyst. How we can identify? So, gases and you can see that reactant and product will having the same phase, and whereas catalyst will having the different phase it will be takes place. So, that is the reason this type of catalyst are called as what about the heterogeneous catalyst. Another one is you know very well, in the preparation of ammonia. Preparation of ammonia, that reaction is Haber's process. In the Haber's process, 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. This is the preparation of ammonia. In this preparation of ammonia, nitrogen is gas, is a 1 mole, hydrogen is also gas, it is a 3 moles, its 1:3 moles react with the compound to prepare ammonia. In this condition, we are using the catalyst is iron, another one is molybdenum. Another one is molybdenum. This iron and molybdenum belongs to what type of nature? Iron and molybdenum. These two are belongs to what type of nature? It is a solid nature is there. So, due to the reason that catalyst is called as heterogeneous catalyst. Here the whatever the product generated, the generated product is also ammonia in the gaseous phase. Nitrogen reacts with hydrogen to form ammonia. These are the reactants, that reactant materials also gas. What are the generated materials is also gas, but what we are using the whatever the catalyst is a solid catalyst it will be takes place. So, that is the reason, that is the example for heterogeneous catalyst. Another one is ammonia plus oxygen, ammonia NH3 plus oxygen, it gives nitrous oxide, another one is water, NO and H2O. In this condition, if you are seeing that, that is ammonia and oxygen reacts with each other to form nitric acid. Here the using the catalyst is platinum is the catalyst. Here using the catalyst is platinum. The platinum belongs to what type of nature? It is a solid nature, it will be there. Ammonia is also gas, oxygen is also gas, nitric oxide is also gas, H2O is also gases. Gases means it is having in the vapor phenomenon it will be takes place. To balance the reaction, how many moles of ammonia means? Here 4 moles of ammonia, 5 moles of oxygen and 4 moles of nitric oxide, 6 moles of water. 4 moles of nitric oxide and 6 moles of water. See that how many nitrogens are here? 4 moles of nitrogen. Here also 4 nitrogens are there. Here also 4 nitrogens are present. Hydrogens 4 3s are 12, 4 3s are 12, 6 2s are 12 hydrogens are there. And oxygens 5 2s are 10 oxygens are there. Now, here these are the 6 oxygens and 4, 6 plus 4, whatever the 10 oxygens are present. So, now this is the balanced equation for preparation of nitric oxide in the presence of oxygen. Ammonia react with oxygen to form nitric oxide and water. Here we are using the catalyst is platinum catalyst. The platinum catalyst nature is, what type of nature is? A solid nature is there. Now reactants and products will having the same phase, but whereas catalyst will having the different phase it will be there. So due to that reason, this type of catalyst is called as heterogeneous catalyst. Another one is vegetable oils. Vegetable oils means that is known as hydrogenation of oils. Hydrogenation of oils means generally we have to say vegetable oils means that one is belongs to unsaturated hydrocarbons. That simply we have to say as unsaturated hydrocarbons. Unsaturated hydrocarbons means it's having whatever the double bonds and triple bonds are there. Those unsaturated hydrocarbon reacts with hydrogen to form saturated hydrocarbons, to form saturated hydrocarbon. Unsaturated hydrocarbons are converted to saturated hydrocarbon. Those saturated hydrocarbons will having the, what about this vanaspati ghee, it will be takes place. Here the catalyst what we are using is the nickel catalyst, that is solid. For example, unsaturated hydrocarbon best example is ethylene. CH2 double bond CH2 ethylene. Ethylene is also what type of material? It is a gaseous material. Hydrogen is also having gaseous material. What we are generated example, the saturated hydrocarbon is ethane, CH3, that is paraffin, it will be takes place. Paraffins also it will be takes place, that is also in the ethane gaseous phenomena. Now here we are using the catalyst is solid catalyst. So due to that reason, the reactants are converting as product. In this process, what we are using the catalyst, based on the catalytic nature, the catalysts are two types, homogeneous catalyst, another one is heterogeneous catalyst. Homo means it's are having in the same phase, hetero means different phase. These are the examples of what about this heterogeneous catalysis. These are the example for heterogeneous catalysis. Another one is autocatalysis. Autocatalysis means the reaction, here we are using the specifically we are using some of the catalyst, but whereas in the autocatalysis, here in the autocatalysis we are not using any catalyst. For example, in the first year stoichiometry, you know very well the example, potassium permanganate reacts with oxalic acid. Potassium permanganate reacts with oxalic acid in the presence of H2SO4. Potassium permanganate, that one is KMnO4. Potassium permanganate reacts with oxalic acid H2C2O4 in the presence of H2SO4. In the presence of H2SO4 to form what about this manganese sulfate, potassium sulfate, water and carbon dioxide. Manganese sulfate MnSO4, potassium sulfate K2SO4, carbon dioxide and water. This reaction we are using for that, what about this ion electron balancing method or oxidation method balancing condition, we are using this equation. Now here we are using the word is autocatalysis. Auto means we are not using any specific catalyst, but in the reaction some of the intermediates are generated. Based on the generation of the intermediate, the reactants are converting as product. That is known as autocatalysis. Auto means self defense mechanism it will be takes place. We are need not to add any external catalyst. In that reaction, intermediate act as a catalyst. In the reaction, intermediate act as a catalytic property. Intermediate act as a catalytic. Through balancing of the reaction, here 2 moles of potassium permanganate, 5 moles of oxalic acid, 3 moles of H2SO4 and 2 moles of manganese sulfate, 8 moles of water, 8 moles of water and 10 moles of carbon dioxide is there for this balancing condition. Now if you see that in that potassium permanganate, so manganese oxidation state is +7 and here in the manganese sulfate, this manganese oxidation state is +2. Manganese oxidation state is +2. In the oxalic acid, if you see that oxalic acid, Here oxygen charge is -2, here hydrogen is +1. So, for 2's 8, 8 minus 2, 8 minus 2 that belongs to 6. Here 2 carbons are there. This carbon oxidation state is +3. Here the carbon oxidation state is +4. Now see that +7 is converted to +2, +3 is converted to +4. +3 +4 means charge will be enhanced, means charge is increased. So that is known as oxidation. If charge will be decreased, that is known as reduction. In this potassium permanganate converted to manganese sulfate. Here in this reaction manganese ions, Mn+2 ions act as a autocatalysis. So here a manganese converted to manganese sulfate, manganese converted to manganese +2. Here how many electrons are difference here? 5 electrons are different, +1 to +7 to converted to +2. +7 is converted to +2 means here how many electrons are exceeded, means 5 electrons are present, +7 and +2. How many electrons? 5 electrons. These 5 electrons are enhancing phenomena is there. Due to that reason, it acts as autocatalysis. Auto means in this reaction, what are the intermediates are there? That intermediates act as a catalytic nature. So, the type of compounds are called autocatalysis. At the same time, in the hydrolysis of ester is also, the generated material is acid. That acid material is also act as autocatalysis property. So, these are the what about the phenomenon of autocatalysis. Next, another one is adsorption theory of heterogeneous catalysis and their mechanism phenomena. Here catalytic property means, for example, if we take, so this is having solid phase. Solid phase means these are the vacant sites are present in the what about the metal ion. Now we are using either nickel or palladium or platinums are there. The nickel, palladium, platinum materials are, what about the materials is a solid material. The solid material will have in the interstitial places will be there. Interstitial places means the small places, it's called as interstitial places. That what about the in that interstitial places we are passing what about the reactant molecule. Now I am taking the reactant molecule is A and B is the reactant molecule. When I am passing the reactants in that what about the particular catalyst, the A and B molecules are placed at the reacting site on the catalytic. Now this is the catalyst, this one is catalyst, that is catalyst base it will be takes place, and A is different compound and B is a different compound. Now this one is, for example, our convenience purpose, these are the reacting site it will be there. In those reacting site, the A molecule and B molecules are placed on the catalyst. Reacting A molecule and B molecules are placed on the catalyst, that is called adsorption. That is called as adsorption. Here you are using the term is adsorption. Adsorption means either liquid particles or gas particles, or in case of solid particles deposited on the surface of the metal. Deposited on the surface of the metal, so that is called as adsorption. Here one is adsorbent and adsorbate is there. The gas particles A and B reacting particles are deposited on the surface of the catalyst. Now these are the individually, A is a stable compound, B is stable compound. When A and B react with each other to form AB molecule. To form the AB molecule, if I am adding the catalyst, those reacting molecules are adsorbed on the catalyst. Those reacting molecules are adsorbed on the catalyst, and what about the some amount of energy will be adsorbed, and having there is a small interaction between A and B. There is a small interaction between, this is the small interaction between here A and B, and after that